So 5 is solving polynomial equations. And I'm going to actually introduce, technically it's 4 new ways of factoring. 2 of them are basically the same-ish. And then one of the ways you may have already been using when you're factoring trinomials. Some of you may have chosen to use it. And then the last way is very much related to factoring trinomials. So we'll knock them all out one at a time. Now, the first thing that we need to discuss, the first new way of factoring, will be sum and difference of cubes. And if you remember, when we were doing factoring, we had something called a difference of squares, right? And there was not a sum of squares, it was just a difference. But for cubes, there's a way to factor a sum of cubes and also a difference of cubes. So this is the one that I was saying is 2 different ways, but it's really basically one way, okay? Now, for the most part, you guys know your perfect squares now. I don't expect that you know your perfect cubes. Well, at least not very many of them. Does anybody know some perfect cubes?
8, 9.
Why is 8 a perfect cube?
2 plus 2 times
2 times 2 times 2 is 8. What would be another perfect cube? 27. Very good. What else?
81.
What did you say? 125. How are we getting these numbers? What are we doing?
Cubing a number.
Yeah, taking a number and cubing it, multiplying it by itself 3 times. So here's a nice little list for you, sort of starter pack of perfect cubes. To the right, yeah, if you want to take a picture, you can. To the right, those are the perfect cubes. Okay? These are my perfect cubes. So all of those numbers are perfect cubes. You should get to a place where you're comfortable with a good chunk of these. I would say be able to go down to at least 125. Get used to recognizing some of these. It'll be helpful later on to start paying attention to these numbers and go, oh, there's something special about that. Maybe I should use it in a certain way. But I would definitely say, 1, 8, 27, 64, 125 for sure. You should know that those are perfect cubes. That will help you get through some of the problems more quickly, or at least point you in the right direction to what type of factoring you should be looking at. You've gotten used to looking at numbers and seeing numbers that are perfect squares going, okay, that's telling me something. Maybe I should work that angle a little bit. Obviously, up here, there's actually 2 numbers that are also perfect squares. Anybody know which 2 numbers of my perfect cubes are also perfect squares? What do you got? Give me one. 64. There's another one.
512.
You can say all the numbers, and eventually, yes, you will be right. But well, no, it's not 512. Let's look at this one. 64. 64 is a perfect square. What do you notice about 4? 4 is also a perfect square. So which other number do you think? 729, correct. Because 9 is a perfect square, 729 is also a perfect square. Its square root is 27. Okay, but I don't expect you to know that. Just a little fun math fact.
So much fun.
Okay, wasn't that fun?
Boy, that makes sense because 3 times 3 is 9.
All right, next we need to get into the actual formulas for sum and difference of cubes. Okay, now you can take a picture of this too. It's also in your book. However you want to get it into your notes, go ahead and get it in, and then we'll talk about how you use this formula. This is a formula you will need to know. I will not be providing it to you. So, yes, you have to memorize both of them, but the reality is the numbers in both problems are the same. The only things that change from a sum of 2 cubes and a difference of 2 cubes are some of the signs. Notice the numbers are all the same. Okay. Now, here's the way I do it. All right, this is the way I think about it, because when I have to generate this formula and use it, this is how I think about it. First off, the last term in this is always plus. So I don't really have to worry about signs, because in my mind, I default to positives all the time. Maybe you do too. All right. I also know that the first binomial sign matches up with the problem. So when I have a sum, this first binomial is the same sign. So there's not necessarily a lot to think about there, but just I have to know that these need to align with this. Difference of cubes, this is minus. Sum of cubes, this is plus. I already know the last one's always plus. And then the middle term is always the opposite of the problem. So sum of cubes, this first middle term in the trinomial is a minus. Difference of cubes, this one is a plus. So that's kind of the only thing you really have to sort of pay attention to, is that middle sign of the trinomial is always the opposite sign of the problem. And then the rest lines up like you think it would, except for the end, which is always plus. That's how I think about it. If that helps you, great, use that. If it doesn't, you got to come up with something else on your own. The key to this whole problem, the key to figuring out any of these and using this sum of cubes or difference of cubes is knowing what A and B are. Once you have A and B, you're just going to identify those. You're going to square them for these parts and multiply them together for the middle part. And so we're going to go through an example where we have to do that. All right. So here's the example. And this is what the directions will look like in your homework today. It'll say factor each polynomial if the polynomial cannot be factored right in prime. You could also just write not factorable. I don't care. They mean the same thing. Whenever you enter a problem that requires factoring, what is the first thing you should check for? Just say it.
Greatest common factor.
Greatest common factor. Very good. So we need to check for a greatest common factor first. Every time, always. Any kind of factoring problem, you need to do that. Is there a greatest common factor here?
Yes.
What is it? Is it 16? Does 16 go into 54? No, it does not. Is it 4? Does 4 go into 54? Does 4 go into 54? No, it does not. Not evenly, anyway.
2.
2? Yeah. 2 does. They're both even.
6.
6? No, 6 doesn't. 8? If 4 doesn't, then 8 doesn't.
Yeah. Oh.
Right? You think about that. If 4 doesn't go into a number, then 8 can't go into the number either, because 4 goes into 8. Can we go bigger than 2 or not? No. What about the variables? 2x. There is an x in common. So so go ahead and do that. Take the 2x out. Factor it out. So here's what you should have gotten. 2x times the quantity 8x cubed plus 27y cubed. What do we know about 8 and 7 now that you maybe didn't know before? What kinds of numbers are 8 and 27? No.
Perfect cubes.
Perfect cubes. Very good. They are perfect cubes. And so are x cubed and y cubed. Those are also perfect cubes. So there we go. We have a sum of 2 perfect cubes.
Why did you keep the x to 27?
Because I divided it out. Okay? Now, here's the key to this problem. What we have to figure out is what A is and what B is. And A is just going to be the cube root of 8x cubed. Okay? Okay, so what is the cube root of 8? Cube root of 8. 2. What is the cube root of x cubed? X. So that's A. A is 2x. Okay, everywhere in the formula, since this is sum, I'm up here. Everywhere you see an A, you're going to plug in 2x. All right? How about for B? The way you find B is the cube root of 27y to the third. What is the cube root of 27? 3. What is the cube root of y cubed? Okay, so everywhere you see b, you're going to plug in 3y. Now, that is sort of the most important work because you have to identify A, you have to identify B. Once you do that, it's just a matter of plugging in the right places for the formula. Okay? Now, here's what it looks like sort of, what's left inside the parentheses is the sum of cubes. We just talked about that already. Now, notice here, I don't care if you write this down this way. What this is really doing is identifying that A is 2x and B is 3y. I don't necessarily need you to write that out like that. Okay, because that doesn't get us anywhere. That just changes this to look like this over here so that we can identify A and B. All right, so that's gonna keep showing up, and one of these days I'll get rid of it, but it's helpful from the perspective of the cube root of 8x cubed is 2x, and all of that cubed, so that's where my A is. The cube root of this is 3y, so that's what my B is. But it's not really that useful in terms of actually figuring it out. Now, of course, also, there should be a 2x here. That doesn't go away. The 2x is always there because it just comes down. But the meat of the problem is going to be factoring that sum of cubes, okay? Now, so when I go to plug it in, right, I'm going to have this 2x here. My binomial, whenever I factor a sum of cubes or a difference of cubes, the sign is exactly the same. So it's just 2x plus 3y. That's the first part. 2x plus 3y. Then to do the second part, here's the way I like to do this, and this is the way I do it to myself. I say take A and square it. Flip the sign from the problem, whatever it is, and then multiply A and B together. Then the last term is always plus. Take that B and square it, and then we'll be done. So go ahead and finish that up. So there's a lot more involved with sum and difference of cubes than what you factored before. But it's not hard if you follow the formula.
Wait, so basically what you did was you took what you got after factor and then put the sum of the two cubes formula and plugged in A and B?
Yep. Why I put the double parentheses here is because when you take A, which is 2x, and square it, don't forget to square the 2. Okay, that's why I put all of this in its own set of parentheses, because one of the mistakes that you guys will make is you'll square the x, but you'll forget to square the 2. So that's important. Okay, here's from the book, a little cleaner looking version, if you like that better. Again, the 2x is still here. It should still be there. But so what they did, instead of putting double parentheses, they did a bracket in a parenthesis. Okay, so here's our final steps here. And then we're done. Because my final answer will have 2x. We'll have a 2x plus 3y. Now, what is 2x, the quantity 2x squared? What is 2x squared? 4x squared. Okay, what do I get when I get the 2x times the 3y? Minus 6 xy. And then what's the last term squared? 9y squared. That is the final answer. That is completely factored now. We wouldn't multiply anything back out because that's the opposite of factor. Right? We're trying to unmultiply stuff, sort of divide stuff out. Okay, this here, what I'm underlining in blue, is the sum of cubes formula in use. Factoring that sum of cubes. Now, I'm not going to do another difference of cubes because the process is the same. You just have to worry about different signs. Otherwise, the process is identical. Okay? And that's what your final answer is. So all of this down here, that is completely factored. So just to clear that up, the actual formula is this side, on the right side of the equal sign. This is like the problem. And so that's why it's written out like this. Because we could write 8x to the third as the quantity 2x all to the third. So that's just establishing what our a is. Again, this is not my preferred way of doing it. When I wrote the cube root of 8x cubed and the cube root of 27y cubed, that's the preferred way of finding a and b. Okay? All right, so you'll do some more of that. Okay? We also need to look at some other kinds of factoring. Final answer, nice and pretty, good. Okay, the next one is factoring by grouping. And like I said at the outset, some of you maybe used factoring by grouping to factor trinomials back in chapter 4 when we were looking at that. And if you did it that way, this is not going to be a big deal for you. All right? But there's a couple situations. Well, there's one situation where we want to be aware of and when you use this. Okay, factoring by grouping is only good to use when you have 4 or more terms. If there are fewer than 4 terms, you're doing one of the other ways that we looked at earlier. Whether it be from chapter 4 or whether it be sum or difference of cubes that we just looked at. But if there are 4 or more terms, you're going to want to try grouping. Now, I'm going to give you sort of a list of directions to follow when you do grouping. And then we'll do 2 examples. Okay. So, here's the first step. You're going to group the first half of the problems, the first half of the terms together and factor it like it's its own problem. So we're going to basically try to take one problem and sort of create 2 problems. So group the first half of the terms together, factor it like it's its own problem. And you should be able then to guess what the second step will be. I'm going to let you do that. So what do you think the second one's going to be? Group the second half, yeah. So copy paste, change from first to second, and you got number 2. Now the third step is where we sort of bring it all together and finish up the problem, okay? And what I'm about to put up here will make more sense when we go through the example. But here's what's supposed to happen, okay? After you factor the first half and after you factor the second half, you should notice that there is a group in common between the first half and the second half. Okay, and then you're going to factor that out. And when we go through the example, it'll make more sense. But that's the purpose of grouping, is that when you split them into first half, second half, there should be a common group after you've done that. Now, I know that this says halves and first half, second half. And we could use them. We're using this method when there's 4 or more terms. If there was an odd number of terms, if there were 5 terms, let's say, then you would group 2 of them together and 3 of them together. And you should still get a common group. That's not going to happen to you, I don't think, today. But most of the time we use grouping, there's an even number of terms. It won't always work out like that. That's probably another course, though. Okay. All right, so here's the example that we're going to do. Go ahead and write that down, and then I will walk you through all the steps of what you want to do with this and point out a lot of different things that you should be looking for. As usual, what should we do first? Is there a greatest common factor here between the whole thing? No, we got even numbers, odd numbers, A's and B's and X's. There is not a greatest common factor. All right. So, what we're going to do is literally group the first half together. So there's my first group. Then I'm going to group my second half together. But for a minute here, we're going to pretend like this second group doesn't even exist. It's gone. Let's just pretend it's not there. Still a little, oops. There we go. Okay? So I'm going to factor this. So what should I do? What do you think? Take out a 4 and an x. Is that it? What do you think? Greatest common factor, 4x. Okay, so we'll pull that out. We got a 4x. What's left? 2a plus b plus c. Do you agree? Okay. Now, here's the really important piece to all of this. In order to use factoring by grouping, what should happen in the second half? What should happen is that I should get another 2a plus b plus c. That's what should happen if it's factorable by grouping. Okay, so let's take a look. What is the greatest common factor in the second half? 3y. Okay, let's say you weren't sure. Understand that I need to turn this 6ay into a 2a. So I take enough out of this to make it a 2a. In this case, you were right. It was 3y. But if you weren't sure, if you just took a 3y out of this, I'd end up with 2a. Now let's see. What's left over? 2a plus b plus c. That's good. I have the same group left over. It's in common. In fact, you want to think about it this way. This is almost like a greatest common factor between those two terms. The greatest common factor between the first half and the second half is that group. So the way we factor it as if it was a common factor, which it is. So I just take it out. So I take a 2a plus b plus c. Well, when I take that group out of this, what am I left with? 4x. When I take the 2a plus b plus c out of the second half, what am I left with? 3y. Okay, that's how you factor by grouping. Okay, we need to look at one more because there's a little bit of a caveat with it that I want you to look out for. And then after I start you on it, you will finish it. All right, so here's the next. The last problem had all the x's together already and all the y's together already. If they weren't, go ahead and write that down. We'll set it up together, and then you'll finish it. Now, one of the things I want you to notice in this problem, and I'm going to flash back to the previous page in a second, is that the thing that's nice is in this problem and the last problem, I have all these terms have an x on them. So like the x's are already sort of put together as one part of it. And on this part, I have a y squared, and all the y squares are put together. Just like on the last problem, let's say this was a y squared and this was an x, you would want to rearrange them. Like if you tried to factor by grouping and it didn't work, look for things like that. Like, look, here are all the x terms. I should probably put them together. All the y squared terms, I should probably put them together. If necessary, you can move things around to make that happen. You okay over there? Okay. All right. So let's look at the start. Okay, so I group the first three together. Then I'm fine. That's not a big deal. There's no issue there. Yikes. Where I have the issue is this, in this fourth term, because of this minus. Here's where you have to be very, very careful. And this is where mistakes happen. Do not split the minus and the 5 apart. That minus stays with the 5 always. So when you go to group, make sure that you bring the minus in. Put a little plus sign there. Okay. One of the mistakes that happen is someone will put a parenthesis in between the minus and the 5, and then you've changed the problem. Because you changed -5 to +5, which you can't just change. Okay. So now we're set up. Factor by grouping. You go ahead and finish. Then we'll come back and look at it together. So here's the thing. A couple things to think about. Because the first set of parentheses is fine, right? Like, what is the greatest common factor? 6x. So I divide that out. I get 5a minus 4b plus c. Okay, so again, a couple things that you need to think about strategy-wise as you approach the second set of parentheses. Your goal is to get another one of these. So one of the things that I saw people do is they factored out a y squared. Okay, and then the first term is -5a, which is not what we want. So that's one thing to think about. Another thing to think about, and I told you this back when we were going through chapter 4, and there was a reason I told you this. When the first term is negative, what should you factor out? A negative. Okay, so when we went through factoring last semester, this is one of the reasons why I say factor out a negative. So since this first term is negative, your greatest common factor here should also be negative. Keeping in mind, I'm trying to get another 5a. So the minus has to go away and the y squared has to go away. So if you think of it from that perspective, you should be factoring out. There's two different ways to think about it. Factoring out the minus y squared. So then that does give me 5a. Now that means when I factor a negative out, these signs all flip. So that's 5a minus 4b plus c, which is good. That's what we want to have happen. So my common group is 5a minus 4b plus c, and I'm left with 6x minus y squared. And it doesn't matter which order you have them in. You could just as easily have written it this way, because we know we can multiply in any order, because what property tells us we can multiply in any order? Commutative, thank you. No end. Questions? Ava?
So then what do you do if there's like 5 of them and then you have to do 3 and 2? Then you won't get the same result.
You could still get the same common group. It just depends on that type of factoring. Because if you have a group of 3, sometimes you can factor it like a trinomial and you'll get 2 binomials. You could have a situation where you had the 2 that were together was like a difference of squares. You'd also get 2 binomials. But like I said, that probably isn't going to come up for us this course. Now, the other thing is some of you maybe were using, like I mentioned, maybe you were using grouping when you were factoring trinomials, and that's fine. So maybe this wasn't new to you. If you like using that, that's great. Okay. Any other questions? All right, next thing. Last thing, speaking of factoring trinomials, I know there's nothing under the remember these yet, but go ahead and write that down and I'll put in what you're supposed to remember. So we're going to factor polynomial equations as if they were quadratics, degree 2. Well, they're not going to be degree 2 though. They're going to be higher degree than 2. But we're going to use the same type of strategy that we used when we factored quadratics. So this is what I wanted you to remember. Here's a quadratic equation. 4x squared minus 8x plus 3 equals 0. We did all this back in the last semester in chapter 4. I showed you all kinds of different ways to solve quadratics. Today we're going to use factoring to solve this quadratic. And I know it's a quadratic because the degree is 2. That's what makes it a quadratic. How many solutions would we normally get from this? 2. Degrees 2, we usually get 2 solutions. Keep that in mind. All right. So, it is now up to you to factor that. Because that's something you're supposed to know how to do. And remember in chapter 4 when I said factoring was going to just keep coming back more and more. You're going to have to know how to do it the rest of your math life. Example number 1 of that. Go ahead and factor that. Go. Let's talk about this a little bit. Because actually I want to show you how you could use grouping for this. For those of you who don't remember what to do, my first move should be I need to multiply 4 and 3 together. That gives me 12. So I need things that need to multiply to give me 12, and that add to -8. Okay? So what are the factors? What factors add to -8 and also multiply to 12? What is it? -6 and -2. Those are my factors. So here's how I could use grouping. Let me just show you this real quick. So that would be 4x squared. What I do is I change this minus 8x into minus 6x minus 2x. And then it would be plus 3. Okay, this is how we use grouping. This is really the box method too, by the way. It's just in a straight line instead of in a box. Okay, so for those of you who still don't quite remember how to factor regular trinomials, you could do this. Now I go to group. Okay, again, slide that minus in, add a plus. What's the common factor between 4x squared and minus 6x? 2x. So when I take that out, I'm left with 2x minus 3. All right, what has to be factored out of this? -1. 2x minus 3. That's good. Common group. What's left over? That's how you factor that. Okay? Again, if you can figure out how to do that, guess and check in your head, great. If you want to use box method, great. There's another way that you can do that. Right. Anyway, that's what we should have gotten, right? Okay. 2x minus 3 times the quantity, 2x minus 1. Now, how do I actually solve it? I haven't solved anything. That was just the factoring. We have to actually solve this. What do I do? How do I solve these two things? Set them both equal to 0. Okay, so when you have two factors multiplied together that equal 0, we set them both equal to 0, right? Then I add 3, add 1, divide by 2. That's how we had to solve quadratics before. Okay? That is not the point of this lesson, however, because you're supposed to already know how to do this. But what's going to happen in this section is you're going to have polynomial equations that are going to be of higher degree than 2, 4, 6, 8, that kind of thing. But the method under which you will solve them will be just like this. We'll factor, we'll set these parts equal to 0, and then we will solve them. Okay, that's what this lesson is. That's what 5.5 is. So, okay, so in other words, the square root of x squared is x. Right? That's the middle term is always the square root of the first variable. Problem again. Because when I come up with the factors, this variable lines up with this middle term. This variable lines up with this middle term. The same, and that's what I just said. Basically going to do the same thing, but with higher degree polynomials. No, that was a problem from chapter 4. That was a problem from November and December. Okay? So the problems that you're going to see today are going to look more like that here. The same other thing will happen. Now, I was kind to you. All right? This is x to the 4th. This is the 4th degree polynomial. So how many solutions should there be? There should be 4 solutions. Now, why did I say I was kind to you? What do you notice here?
4, 2. It's the exact same thing, but with squares.
The coefficients are all the same.
Oh.
Yeah? 4, negative 8, 3, which means the factoring part of it, we already did. Okay, in terms of the numbers, how we deal with the variables is going to be different. And that's the part you really need to pay attention to. But understand that this can be factored just like a quadratic. And what's important to notice is that this term, x squared term, is the square root of x to the fourth. And something you probably didn't realize before when we looked at quadratics is that first term that was an x squared, the square root of that was always the term of the middle term. Let me flash back. The thing will happen today. The square root of x to the fourth is x squared, which when that happens, we know that we can use the strategies that we used factoring quadratics in problems like this. Okay? So the only difference here, and let me go back here. The factors will have an x squared now at the front instead of an x. All right? So when I go to factor this problem, we already know that it's 2x minus 3, 2x minus 1. But instead of being x now, it's just x squared. That's the difference. Okay, so the factoring part of it ends up giving me the same numbers. The variable term changes based on what this middle term variable is. Now, if we hadn't already factored this problem out that way in the previous quadratic, you'd go through the same motions. You'd be like 4 times 3 factors that add up to negative 8. You'd find the factors. You could group it or box method it or whatever to come up with this. Just know that this first part will line up here. Okay? All right, so if you were going to use the grouping like we did on the last one, what you would have is, actually I will write that out. What you'd end up with is 4x to the fourth, if you're going to use grouping, minus 6x squared, minus 2x squared, plus 3. So these numbers would still be x squareds. But the rest of the problem is the same as what we did. Okay? Now, something else the book does, and I'll show you, I can't remember which variable they use, but sometimes what they'll do is they'll tell you, okay, just substitute in, just change the variable, make z equal x squared, and then change the whole problem to say 4x squared minus, sorry, it wouldn't be x, 4z squared minus 8z plus 3 equals 0. And you'd go through and solve it, and you'd solve for z, and then you'd have to replace z with x squared and go from there. I'm not a fan of that. I don't think you need to do that, but if you want to, you're welcome to. I'm not a fan of that, though. I think we can just make the jump without substituting it. Okay? Now, the rest of the problem is basically the same as what we did before. I set each equal to 0, and I solve. Okay. So here, now I'm going to add 3, I'm going to add 1. I'm actually going to put that out there this time. And then what's my next move? Nope. Divide by 2, okay? All right, so instead of solving for x, I'm solving for x squared. But we don't want x squared. We have to take another step. And so when I take another step, what does that look like? What's my next move? Square root. And when you square root, what else do you have to include? Plus or minus. Very good. Okay. So here we go. X equals plus or minus square root of 3 over 2 and plus or minus 1/2. Square root of 1/2. So there's my 4 answers, right? I'm done? I mean, I got a positive square root of 3 over 2, a negative square root of 3 over 2, a positive square root of 1/2.
Is there a way to never, Mr. Or isn't there like
Does it sound like? Do I sound like I'm trapping you?
no, it's
Setting.
last
Set,
time
I think we're
we
done.
could either stop
I
there
feel
or
like there's nothing else we could do.
or it just depends on the total.
all right.
Guys, I
Well.
call it a day.
Yeah, it sounded kind of trappy. All right, now, what does the square root of 3 over 2 actually mean? No.
It could be hardly ordinary.
What's
Oh, the square root of 3 over the square root of 2.
square root of 3 over the square root of 2? And what's this one then?
Square root of 1 over square root
Yeah, that does. Okay, anybody see a problem now?
of 2. Yeah.
Oh my gosh, you have to do that. Yeah.
What's the problem?
Too much.
Multiply the bottom by
Wait. Just identify the problem. What's the...
a radical.
Can't have a radical denominator. Yes. Yes, you cannot have a radical in the denominator. That is true. And so now, David, what do I have to do in order to get rid of it?
Multiply the bottom by square root of 2.
Square root of 2. No, you can't just randomly square things. You can multiply top and bottom by the square root of 2 and do the same thing over here. Remember this now too? Okay. Now. Well, what is this actually on the bottom? What is the square root of 2 times the square root of 2?
1, 0.
No, what? The square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay, what's the top here? What's the top here? Square root of 2. Okay, so in reality, this is the square root of 4, which is 2. This is just the square root of 6. This is the square root of 2. Now are we done?
No.
What do you think? Do you think we're done?
I'm so confused.
There it is. We are done.
So we did we multiplied the square root of 2 over square root of 2 because that was the denominator.
Yes.
Oh. Never mind.
Yes.
I'm confused.
In order to get rid of the square root of 2, we just multiplied it by itself, basically, which I know in your mind is squaring. But you can't just square the top and bottom. You have to multiply by the square root of 2 and the square root of 2 to give me, this is all just 1. Okay? Now, here's the thing. This isn't always going to happen where you have to rationalize the denominator like we did. Sometimes this is going to come out to be just a regular number, not a fraction. It's when it comes out to be a fraction that you're going to have to watch out. Now, if this was a 3/4, then we'd be fine, because the square root of 4 is 2, and we would have been fine already. But so you're going to have to look out for that, and otherwise, the rest of them are just similar to that. Okay? Question? In a minute.